Joel and Linda in the
afternoon.
Okay then. So usually when we do this, we're doing physics. What are you doing this time?
Well, this time we've been doing waves, all kinds of waves.
Oh boy.
Sea kind of waves, sound kind of waves, Mexican waves, all sorts.
Mexican waves?
Yeah, like in the football stadium, soccer stadium. When like one lot of people stands up and the next, yeah, you do.
I've never heard it called that before. Whatever.
Okay, well I know it as a Mexican wave.
Okay. What? Just.
Okay, so waves.
Waves.
Anyway.
Sure, it's coincidental. I'll hold the guitar for this.
Yeah, because I need the idea of sound to be part of this. So the first thing I was thinking about is when you make a sound on the guitar, yeah, like that, proper sound, it kind of comes out of the resonator of the guitar.
Right.
It hits our ears, doesn't it?
Yeah.
And you've heard of sound waves.
Yeah, if I'm not mistaken, that's basically just a pressure wave. It's like
yeah, it kind of is. So when the sound kind of comes out, it's the sound is made by molecules vibrating together.
Mm-hmm.
So the vibrations kind of crunch up and move through the molecules until they hit the little sound receptors in your ear. So
there we go.
I always thought that somehow sound waves moved through the air, but they actually don't. They jostle.
It's not really through. It's just pushing each other.
Right, and so they jostle and crunch up in one place, and then that moves on sequentially through.
It's something like how in an explosion
molecules.
you kind of see like a ripple in the air after the explosion. That's kind of like what it is.
Maybe. I don't know. I haven't watched many explosions. That's your obsession.
Yeah, fair enough. Well, we watched the MythBusters, haven't we? Or was that a little bit too long ago?
Yeah, but I don't know that was necessarily. Yeah, I guess that was the idea of a wave, like a pressure wave.
Yeah. Yeah.
So and those are called longitudinal waves because the direction that the wave is traveling is also the same as the impulse.
It's not going up and down it's not going up and down.
Right. So the impulse to create the wave is in the same direction as the wave.
Right.
Parallel with travel. So the other way that waves happen is transverse. And that's what you're doing when you pluck a guitar string.
So that's what the guitar string does.
Yes, it moves sideways. So transverse means to cross, to transverse.
Right.
To cross.
It moves up and down.
Yeah, and in terms of up and down, you mean up and down perpendicular to the string.
Yes. Yes.
So we know that guitar strings come in different thicknesses, and you can change the pitch of them by making them tighter or looser, and that's what the screw heads are for, isn't it? So I've got some elastic in my pocket because I thought this might be able to show the whole idea of how loose or taut. Here, hold that. So if you pluck the elastic,
Okay, yeah.
you can see that it has a certain bounce, and when the distance that it moves away from the center is called the amplitude. So don't don't interfere with it. But the interfering with it is what you do when you make the chords. So if you hold it there, but you also hold it there, so you're limiting the
With the chords, you're more or less pinching it against the little bumps in the neck. I don't actually know what those are called because it's been a while since I've actually done anything with guitar.
So that completely changes the wavelength, because the wavelength right now is defined by where we're holding it. But then if you put a stop on it somewhere else, that shortens the wavelength to that. Alright. And if you make it tighter, the pitch goes up. So hold it real tight. I don't know if the
I don't.
phone camera will
Yeah.
pick this up. We'll see. But so that's just a little bit on the idea of weights. All right. Thanks, Joel.
All right. Cool.
See you later.